All right, I hope this is working. Looks like it is. We will start momentarily. Testing, 1, 2. All right, so I think we are almost ready to begin here. Looks like a few people have joined, which is great. So welcome to the first live lecture for the POSA Communication MOOC, which is the second MOOC in the POSA series, and of course the fourth MOOC in the mobile cloud computing with Android specialization. What I'm going to do today is I'm going to talk about a couple of, I'll give you an overview of what's going to be in the class, and then we'll jump right in and start talking about bound and started services. And of course, you're always welcome to chime in with any questions you might have. So let's first go start talking about what the MOOC is about. So this particular MOOC, like the other MOOC, is organized in a very stylized kind of way. And we're going to talk about that in just a second. Let me make the screen a little bigger. Okay, so this MOOC is organized in a couple of different ways, and we're going to talk about the structure and contents of the MOOC. And this will only take maybe 5 minutes or so. It won't take very long. So there are 3 main sections, and of course a little introduction, which is just there to kind of hold it all together like a conductor. And the real meat of the course will start momentarily, where we're going to begin talking about Android services and local inter-process communication. And this is very nice because it complements the concurrency topics we covered in the previous MOOC, which were focusing more on the kinds of things you can do in the context of an activity. And now, of course, we're going to start talking about services. And as you'll see, services are really nice because they help make it easier to run things in the background, and they help to do long-running computations, and they avoid a lot of the headaches that we ran into with some of the issues with doing concurrency in activities. We'll also talk about local inter-process communication. And local inter-process communication are basically ways that you can have activities talk to services, and services talk to activities, and services talk to other services, and so on and so forth, within a mobile device itself, which of course could very well have lots of memory and lots of cores and other things you've come to know and love with processes and threads in the context of Linux and Android and so on. But we'll talk about a number of different communication mechanisms, ranging from messengers to the Android interface definition language and a bunch of variants that are kind of in between. So that'll basically cover this week and next week's lectures. Then after that, we're going to talk about remote inter-process communication. What is remote IPC? That basically deals with things that go from your device to a server somewhere, a cloud server, a data center server, could be another Android device, but typically it's going to be talking to a server. And for this section, we're actually going to be joined by Professor White, Jules White, who is also going to be doing the mobile cloud computing MOOCs together with some help from me. And he's going to talk about HTTP. He's going to talk about designing mobile applications using HTTP style communication with Apache and Java.net and so on. And he's also going to talk about more advanced client-side communication abstractions, things like retrofit which make it more like an RPC call, remote procedure call, or remote method invocation. And that'll be section 2. And then after that, of course, we're going to talk about patterns. And we'll be covering, about 4 patterns. Maybe we'll do another one, but I think we'll definitely do 4. We'll talk about the activator pattern, which gets used for services and other entities that have to be launched. We'll talk about the command processor pattern, which we covered last time, except this time we're going to be focusing not in terms of the Hammer framework, the handlers, messages, and runnables framework for concurrency within an Android activity, but we're actually going to be talking about the use of the intent service, the Android intent service, which is another example of the command processor pattern. We're then going to talk about a couple of variants of the broker pattern. We'll talk about the proxy pattern, which is used by the generated stubs and proxies that come out of the AIDL compiler. That's what's the proxy pattern, and that's used to provide you a method call oriented interface to communicating between separate address spaces using the broker pattern. And we might also kind of talk a bit about the active object pattern, because active objects apply here as well. So we'll cover 4 or 5 patterns in this space, and I'll reference them throughout the discussion, and then I'll explicitly talk about them at the end so you get to see how they work. Some of these patterns are sort of infrastructure patterns. Other patterns are patterns that involve infrastructure and applications. They're all useful things to know and understand, both within the context of Android as well as in other systems that do communication. And this MOOC is different from the previous MOOCs that we've done. If you take a look at item 26 in the FAQ, you'll see some examples of the other MOOCs we've covered on communication plumbing, which is what the pipes are showing here. And basically the difference is we have a lot more material on services and inter-process communication, both local and remote, that we didn't really cover in previous MOOCs. And that's going to help a lot when people get to the capstone course, because you'll be able to be more confident in doing things with respect to the MOOCs. Okay, so that's basically what we're going to be covering. I think what I'll do now is I will go ahead and switch over and start sharing my screen, and we'll talk about some of the things that will be going on there. All right, so let's go find the presentation, and we will go ahead and cover it. Let's see, here we go. Okay, hopefully you can see that. So the first topic we're going to cover has to do with Android services and local inter-process communication. And we'll talk about the motivations for and the capabilities of Android services and the steps involved in implementing and configuring these services. And we'll also spend a little time talking about concurrency in Android services, which is an important topic that continues the topic we covered in the previous MOOC. And then I'll also give a complete example. I'll walk through a complete simple example that illustrates the use of services, which you can download and play with at your convenience. All right, so first let's talk about, why do we need Android services? Well, it turns out if you paid close attention to the end of the last class, at the end of the last MOOC, it turned out that Android activities have several limitations for long duration concurrent operations. And this became clear through watching the videos, listening to the discussion board forum postings, and responding to them, and so on and so forth. Here are some of the limitations that you run into when you're trying to use activities for long duration concurrent operations. One thing, as we discovered, especially in the last assignment from the previous MOOC, if you're going to be using concurrency with activities, you have to be able to program those activities to handle runtime configuration changes. So when the orientation changes from portrait to landscape or vice versa, you have to make sure that your code handles that properly. And while it's not that difficult to do, once you understand a few patterns and you understand some mechanisms that come in Android, like retain fragments, it still is awkward, and you have to think about it, and it makes your code a bit more complicated and probably error prone. And undoubtedly, if you do it wrong, you won't discover for a while that things are incorrect, and it'll come back to bite you. Another thing you have to deal with whenever you have an activity, whenever you have operations running an activity, the user may press the back button, in which case that activity needs to be destroyed. You don't want to have things continuing to run once an activity has gone away. And so you're obligated by the rules of Android programming to clean up your device, your context and your application activity information and state and so on when the back button is pressed. And so having activities be the sole place that you do long-running computations is brittle, because a user could kill them at any point, and that you may die halfway through something that's important that you don't realize you want to come back and restart later on. And then another issue that we talked about quite a bit in the discussion forums and in the videos were that activities are stacked when they're started. And so if you start another activity while one is currently running, the one underneath it is kind of pinned, and at least in theory probably shouldn't be doing a whole heck of a lot while the other one is running. And so using activities purely as a way of doing the units of work or computation is a little bit awkward because of the fact that they kind of stack. And so things may sort of serialize in ways that you don't intend, and it makes it harder to write very complex applications. Now, if you take a look at my solution to assignment number 3, you see a cool use of the state pattern in order to be able to kind of have activities come and go in a microservices architecture-like model. And that's kind of cool, but not every application needs to be designed that way. And so, as we'll see, there's a need for being able to do something above and beyond what you get with activities for long-running stuff. So that, of course, begs the question, what is the mechanism, or what are the components needed to perform long-duration operations concurrently in the background? What is the right approach for doing that? Well, naturally, that motivates Android services. So I'll give you an overview of Android services, and then I'll stop and take any questions that you might have. So unlike activities, services do not interact with the user directly. If you try to interact with the user, then bad things will happen. And there's all kinds of problems with trying to call activity level operations like widget kind of things and views and menus and dialog boxes from a service, not the least of which is services can actually be configured to run in a totally separate process. Therefore, they will not work at all when you try to access the user interface, because it may not be attached to a user interface at all. If you read this link, it'll talk more about what a service is and its role in Android's architecture. What you can do with a service, however, is activities or other services can use a service to perform long duration operations or to access remote resources in the background. And typically the idea here is that things that need to be running in the background, things that don't want to be affected when you rotate your application or you hit the back button, or you want to be able to give more fine-grained levels of concurrency than you can do by having activities as microservices and so on. These are the kinds of things you might want to do in a service. So here are some examples. These are examples that either come from Android or we'll implement in this course. One thing is play music or videos on a device. This is typically done by a service because you need to have it run. Even when you move yourself away from the display to the music player, the music still continues to play in the background. You might want to synchronize the contents of an email, contacts, calendar, MMS, SMS, various databases you have on the phone with databases that are stored on cloud servers. And a service is a very canonical way to do this because it runs in the background and doesn't have to be attached to an application directly. And then, of course, something we'll talk about a lot in the examples we'll use and some of the homework you'll do, some of the programming assignments, is downloading and storing and displaying images. And so as you'll see, the downloading and storing images is something that works quite nicely with a service, and you'll get lots of examples to play around with this using a microservices-like model. Microservice being a pattern, microservice architecture being a pattern, service being an Android component that you could use to implement microservices or macroservices for that matter. If you take a look at this link, you'll find a nice example of a download application that uses services, and that might be a good place to look for some of the assignments, although of course the assignments will not be identical to what's in that example. Typically, services are launched by activities. There's a couple different ways to do it, depending on what kind of service you're doing, and the activity are responsible for starting the service. Services can also start other services, but that's not as common as having an activity start a service. The service can run in the background, and it'll continue running even if the user switches activities or returns from an activity, or even if a runtime configuration change occurs. The service is not affected at all by those kinds of changes. A service shouldn't access the user interface directly. If you try to access the user interface, bad things are going to happen. And instead, what you should do is you should use an inter-process communication mechanism. And we'll see a whole pile of them later that you can use to talk between activities and services. In fact, that's the next topic. I mean, the topic of the next 2 weeks is largely services and inter-process communication mechanisms for communicating between activities and services. Something else to remember, and we'll talk about this a lot more later, a service may or may not actually run in a separate background thread or process. In fact, when a service is first created, it doesn't have a special thread or a different process unless you do something to change it. And so that's always important to keep in mind, that a service really needs to get a little bit additional programming or configuration in order to do its thing. We're going to cover 2 types of services in this course. We're going to cover started services, which are described here. A started service is launched by start service, surprise, surprise, and you can pass parameters to the service as extras to the intent that's used to start the service. This is just like you can pass extras to the intent used to start an activity as well, same basic idea. That's not always the best way to do things, but for certain kinds of services, it works pretty well. A started service often performs one operation. It doesn't have to, but it often just does one thing. When it's started, it does one thing. And it doesn't need to return a result to the client, although it may, and we'll see how you might want to do it if you choose to do that. And a started service typically shuts itself down when it's done. And it usually shuts itself down as soon as there's no more work for it to do. So that's a so-called started service. It can also, of course, be stopped when the activity explicitly calls stop service. A bound service is a little different. It's a little bit more powerful in a lot of ways. And at first glance, it seems more complicated, but what you get when you're done is a more featureful set of capabilities. You can read more about bound services here. A bound service is launched by bind service. Instead of start service, it's bind service. And that involves a much more complicated protocol, which we'll look at shortly. You can use a bound service to implement an extended two-way conversation between a client and a service, or between clients and a service. So what you could do there is, once the service is properly bound and initialized, then the client and the service can pass messages back and forth, either weakly type messages using the messenger abstraction we'll talk about, or strongly typed messages using the AIDL stubs and proxies that we'll talk about. Unlike started services, which really have to kind of manage their own lifecycle explicitly in the code, a bound service is automatically destroyed when all clients unbind from it. So that way it reference counts itself, and when it reaches 0, it turns and goes away. So it's kind of easier to keep the lifecycle management of a bound service working properly. In addition to started services and bound services, Android also supports something called system services. And system services expose low-level functions of the hardware and the Linux operating system kernel up to higher-level applications and application services. So here are some examples of things we'll talk about a little bit. One of the most important services is the Activity Manager service, which is a system service that basically is used to manage the life cycle of activities and application services and broadcast receivers and so on and so forth. And of course, there are other services here too, like power management, telephony, package manager, location manager, and so on and so forth. You can read more about Android system services here at this link. Okay, that's a good stopping point. So let's stop for a second and see if there are any questions. So one good question, are we going to cover authentication with a web app over JSON? So we will be talking about, in this particular MOOC, we will be talking about using JSON to communicate from an Android device to a web service somewhere. A later course in the MOOC will go through all the security topics in great detail. So the course that's on mobile and cloud security will really go into much greater detail about the authentication part. So we are not going to talk a lot about that in this MOOC, but it will be covered, of course, by the time we're all done. Let's see, question about stacked activities. So if you take a look at the slide where I mentioned the word stacked activities, you'll see a link to a discussion of tasks and the backstack. And if you read that link, you'll discover, which you probably already knew, of course, that Android stacks up the activities. And so there's always an activity that's on the top of the stack, and that's the one where the user is interacting. And if you hit back, that's the one that's popped off typically. And so take a look there and you'll find out about how activities are stacked. And of course, that has a lot of implications for various kinds of things, because that affects what happens when you rotate the phone, that affects which activity is involved. When you hit the back button, that affects which activity is involved. You can also rearrange the stack by going to the task manager and bringing other things to the foreground, and so on and so forth. So that's basically what stacks mean. Let's see, can an application stop or hijack a service that's been started by a different application, or does the service simply replicate itself for each application? Great question. It all depends on how you configure it, and we'll talk more about configuration here shortly. Basically, if you have a you can make a service that's just local or even private to one application, or you can actually have the service run in its own process and then be shared by multiple applications. And we'll see examples of both. There's examples of both in Android, and we'll see examples of doing both in the class. And you'll find out it's very easy to do that. Will I be able to make a chat application using a MySQL database when I'm done using a service to catch incoming messages? So this particular MOOC is not going to talk about MySQL, or it's not going to be talking about SQLite, which is the Android way of doing things. By the time you're done with the specialization, however, of course you will be, because we'll be covering SQLite and other types of database access, MongoDB and SQL Server and other cloud-based mechanisms and so on, when we talk about mobile cloud programming, which is the 5th MOOC in this specialization. So that'll start in a month and a half or so. Let's see, well, we'll be offering the previous MOOC again. We are planning to offer the previous MOOC again, and we'll probably do it again once this one is done. Let's see, so the system service is kernel level, and starting and bound services are user level services. No, not really. Depends on what you mean by kernel, of course. The Android Linux kernel is not related to these system services. The system services run as processes in the user space of Linux, but they have special privileges that they are given, and they can access things typically through the NDK, the Native Device Kit, or Native Development Kit, NDK. So they're closer to the metal than an Android Java service, but they're not implemented in the operating system kernel. If you want to see some good examples of services, we'll talk about some later. One of the interesting services, of course, is the Activity Manager service, which is written in Java. There's also other services like the Media Player service is written in C++. And it's really, really interesting to look at that code. Very complicated. I should also point out that you can write services in both C++ and C and Java. Is there a bind procedure to system services? Can another app unbind other clients? So I don't think you can unbind other clients. The Activity Manager service, of course, can unbind things at its will. And so system services are programmed in a slightly different way than a regular service, but it's not that much different in terms of the way things work. I didn't finish the 2 earlier courses, but I have previous experience in Android programming. You're welcome to continue the course, of course. Take a look at the you're well advised to go back and watch some of the earlier videos, because at least in the previous MOOC, because I will be assuming that people understand some of the things about Android concurrency. I'll be assuming people know what the Hammer framework is, for example. So you really should go back and watch some of those videos. I think that was week 2 from the previous MOOC, the MOOC on POSA concurrency. Some of the other stuff that we talked about in the last MOOC, like the async task framework, we're not really going to look at async tasks very much. They don't apply in services. They're really only good for using them in activities for a variety of reasons. But you're welcome to try it out and see how you do. And I welcome you, but just be prepared to do some remedial work if there are things we talk about that you don't quite understand yet. What different messaging applications use what type of services? So I'll give you some examples here towards the end of this talk about some of the services that are built into Android. And of course, it's absolutely trivial to find this out. All you have to do is download the Android source code and then just search for extends service or extends intent service, and you'll find all the services, which is what I do. So I'll talk about that before. Let's see. Why did we learn in the past course things we're never going to use, and it's not the way to do this, because in this course we do it with services? Why don't we have real example of patterns? So everything we talked about in the previous course is perfectly legitimate, except that there are often alternative ways to do it, and depending on what you're trying to do, they may be better. So the purpose of the previous class was to focus on concurrency and activities, and we covered lots of patterns that are very relevant to Android. We covered the command processor pattern, which is very relevant to Android. We covered the active object pattern, which is very relevant to Android programming. We covered thread-specific storage pattern, which is very relevant to Android programming with activities and so on. We covered half sync, half async, which, as you saw, is very relevant to the async task framework. So there's nothing we covered last time that is not relevant. It's just that depending on what you're doing, there are often other ways that are better to do things, but they're not always the right thing to do. So there's plenty of situations where you would choose not to use services, where using activities are a perfectly reasonable thing to do. And so there's nothing that you learn that will not come in handy in one way or another. Moreover, some of the things we talked about, like the microservices design using the state pattern, is really kind of the cutting edge of software architecture today. So the fact that people who built Android applications 3 or 4 years ago didn't do that approach, that doesn't mean it's not relevant. It just that it took a while for people to become aware of what a microservices architecture was all about and how to use it more effectively into their programs. So you'll discover that everything that you learned will be useful to you. Will we learn how to define a JSON API? Yes, you will learn how to use JSON in the later parts of this course. It'll probably be starting around week 3 or so. Why is the service executed on the user interface thread by default instead of on a background thread? Well, that's a good question. You really should ask the designers of Android that question. You can post something to the message board, and maybe Diana Hackborn or Romain Guy or someone else will come and reply to you. But basically, they did that, I think, so that people would have maximal flexibility for how they used services. In fact, I will show you an example here shortly today of programming a service for streaming music to your phone that runs entirely in the UI thread from the user level programming perspective. Now, under the hood, it takes advantage of some cool features that are part of the underlying Android media player application to actually do some of the work in the background. But you'll see that there's no reason why you always need to run your services off the UI thread. So there's no reason you have to do it, but Android gives you the mechanisms to do it if you so choose. Let's see, somebody wants to know, if I communicate with my own SQL database on a remote server, how will a service help me in terms of creating the chat app? So obviously, I'm not in a position to give you consulting on your specific app design, but as we go through the material on services, and if you get impatient, you can always watch the pre-recorded videos and you can see what we're going to cover if you're interested in an overview. You'll see how this all works and why you would use it and so on. You would typically use a service if there was something that you needed to do in the background, even if your application activity was not active at that point in time. And maybe a chat app would be good for that. Maybe it wouldn't. Maybe you want to buffer stuff. Maybe you don't. So there's no hard and fast reason for using these things. We'll have to talk through them as we go. How many assignments and quizzes do we have in the course? Please read the FAQ and you will discover these things. I don't want to spend time going through stuff that can be answered by reading the FAQ. So go take a look at the FAQ. We'll basically have 3 assignments just like we did the last class, and we'll probably have 4 quizzes. But read the FAQ. System service is kernel level? No, system level is not kernel level. System level is system level, but it's not running in the kernel. It's running as an application process in Linux. Will we be discussing design patterns about communicating between fragments, activities, and services? Yes, absolutely. If you are interested, you can watch ahead to the pre-recorded videos for the first couple weeks, which are all available on the website, and you can see some of the topics we're going to cover. Obviously, the live discussions tend to be more sophisticated and cover more topics in depth because they're more recent based on things I've done recently, but you'll get an overview of the things we're going to cover. How will you keep services across a device reboot? Well, obviously, depends what you mean by that. I think what you might mean by that is, will you learn how to store data persistently so if the device is rebooted, the data is not lost? And of course, the answer is yes. There's all kinds of ways to do that. We'll cover a little bit of that in this course, and then that'll be covered more in the course on cloud programming and mobile to cloud programming, where we'll cover content providers and databases in more detail. Obviously, a service, just like anything else that's running in memory, will not survive a reboot, but you can certainly make your data persistent. And there are really easy ways to do that if you want to. One thing you could use is a shared preference if you just want to store data persistently without worrying too much about how it's stored. Under the hood, it's stored using a persistent hash map, which is kind of fun. Let's see. Does it make sense to do this MOOC first and then the one you finished last week? Well, again, it's up to you to do what you'd like to do. This course assumes people have knowledge of what was covered in the first course, so you're welcome to give it a shot. But if it goes too fast, I would recommend you go back and do the other one first. Are services of one app in the same process JVM of activities? Yes, by default, a service runs in the same process as the activity that started it. But as you'll see very shortly, it's trivial to make it run in a separate process. Is a service similar to daemon in Unix? It's not unlike a daemon in Unix, but it's not a daemon in Unix. You can think of it as being something that is not connected directly to the user interface, and so as a result has to use communication mechanisms to talk back and forth between things that are connected to the user interface. Okay, can I have a service that starts when the phone is started? Yes, absolutely. That's kind of what the system services do. They start up when the phone starts, and if you want to spend additional time learning how to do started services, then you could certainly start a service when the phone starts. That's typically not recommended unless you really know what you're doing, because of course that will sit there and take up space and time and so on. But it's certainly possible to do so. And all the obvious services in Android are all booted when the phone starts up. Okay, so that was a good discussion of the questions. That finishes the questions for now. Let us go ahead at this point and start covering the next set of topics, which we will do right now. So the next set of topics we're going to cover are how you go ahead and implement a service. And we'll see there's a couple of different parts of this because it's a fairly complicated set of things to be aware of. First of all, the thing you need to do is go out and read the documentation on service. This will give you a nice discussion of some of the things we're about to talk about. This gives you more details, of course, in the documentation, but I'll give you enough information to make sense out of what it's doing. Implementing a service in some ways is similar to implementing an activity. For example, and if you take a look at Professor Porter's MOOCs, he has lectures on how do you implement activities. Service and activities are both programmed via canonical framework techniques. And what does that mean? We've talked before about what is a framework. A framework has basically a set of components that are integrated to provide a family of reusable capabilities for applications that share common requirements and common mechanisms and common implementation artifacts and design artifacts. And a framework has domain-specific functionality, inversion of control, and semi-complete portions of an application. And so what you'll see with both activities and services in Android is under the hood, they're all managed by something called the activity manager. And the activity manager is one of the services, one of the system services that's always running. And it basically is responsible for calling back on various hook methods when a service, to control a service's lifecycle. Here's where the source code is for the activity manager service. It's quite a gigantic piece of code. I think it's about 20,000 lines of code, and it's quite interesting to read. I've read it, and we may go over some of it later. So some of the things you do, of course, is you extend the Android service class. If you take a look at this link, you'll find the Android service class. And you can either extend the service directly or indirectly. This example I'm going to give you here is one where we're directly extending the service. But if you use the intent service, then you can indirectly inherit from service. And the intent service, as we'll see later, gives you a whole bunch of other cool things related to concurrency control. There's a whole bunch of service-specific lifecycle hook methods that are defined in service. And you have to override some of these in order to get the job done. This, of course, is one of the characteristics of inversion of control that you find with a framework. So Android Service Framework, which is implemented by the Activity Manager service, which is kind of a funny name because it also manages services and broadcast receivers as well as activities. This is what handles inversion of control. You can read this link for more information about inversion of control. Inversion of control just means the system framework calls back your application code at certain points in time or under certain circumstances when events occur, and you are responsible for writing the code to handle those callback methods. You can selectively override these hook methods. I'm going to talk about all of them in a second, so I'm not going to cover them here. When you implement different kinds of services, and we'll talk about different kinds of services in a second, you'll see that there's different hook methods that you are obliged to override. Sometimes you have to override many of them, sometimes just a few of them. It all depends on what kind of service that you're actually making and what you're doing with that service. And of course, in addition to defining these hook methods that are inherited from service, there'll also be other things that you need to provide. So you may need to have factory methods, you may need to have other classes, either nested classes or other classes that you use in order to get the job done. And oftentimes, these other methods and classes implement the real application logic, as well as any communication and concurrency behaviors that are important. And so we'll see how all those things get used many times over. Let's talk about some of the mechanisms with Android. So there's a method called onCreate, which is very similar to the onCreate method that we have with an activity. A little bit different signature. It's not passed in a bundle, but basically it's called when a service is first launched, no matter what kind of service it is, a bound service, a started service, and so on. So that's kind of the virtual constructor. It's where you do one-time in initialization behavior. All right, let's talk about other things you have to do to implement a service. The next command is called onStart command. And this is called every time a started service is sent an intent via start service. So whenever a service is started by an activity or another service, the onStart command is called. And that's only when it's a started service. If it's a bound service, things work a little differently. So, of course, onStart command is what's used to figure out how to actually process the information that's stored in the intent that's passed to start service. And of course, you can put other kinds of information. You can put in the data element in an intent. You can put extras into the intent. You can get anything you need out of that particular intent in order to pass information to the started service. And of course, the service has a variety of different options for how it's going to process the data concurrently. If it's an intent service, it has its own thread with its own message queue using the Hammer framework from the Android concurrency portion of the MOOC we talked about before. You can also spawn your own threads. You can do a variety of things. You can use Java executor framework and thread pools, et cetera, et cetera, et cetera. There's lots of stuff that can go on there. We'll talk about a lot of those examples, and you'll get a chance to implement some of them in the programming assignments. Then there's also a set of methods that are used for bound services, on bind and on unbind. And these are used in order to set up the connection between the client and the service so that data can flow more readily between them in an extended conversation. It's typically a two-way conversation, request-response style of conversation. So on bind and on unbind are used when bind service and unbind service are called. And on bind receives the intent passed by the client's initial call to bind service. This is a little bit squirrely, however, because it's only the first intent that's passed in that's called. So you really can't use the intent to communicate much of anything interesting to a bound service. Instead, you would use other inter-process communication mechanisms like the messengers or the AIDL proxies and stubs. On bind is a factory method that returns an inter-process communication channel to the client. And we'll see how that works later. That's basically used to return a, it's called an iBinder, but it's basically an IPC handle that you can use in order to be able to communicate from activity to service, irrespective of whether that service runs in another process or not. And we'll talk a lot about this stuff later. This is a very interesting and powerful aspect of services, is the ability to communicate with them with strongly typed method calls. On unbind is a disposal method that's called when all the clients have disconnected. So when all the clients go away, on unbind is called back, and that gives you a hook to decide what to do next. And then, of course, on destroy is used by both bound and started services to shut down the service. So you can think of on destroy as effectively a virtual destructor. And this method cleans up any resources held by the service. All right, so let's see. There are a couple of questions here. Let's go take a few questions before we continue on. So someone wanted to know whether callbacks are an example of inversion of control. Typically, yes, especially if they're callbacks that come from a framework that owns the event loop. Generally, callbacks, though, are inverting control, but they're particularly inverting control when the callback is driven by the framework that owns the event loop. And that, of course, is what happens in Android all the time, right? You do not own the event loop in Android. The activity and the main activity thread, or rather the activity thread, is where the main program runs in Android, and it basically sits there and just drives the entire application with callbacks via the looper in the user interface thread. If you go back and watch the videos from last time where we discussed how the Android activity works and the activity thread, you'll see how this all works. So that's a really good example of inversion of control, because you don't own the event loop. You don't control it. It's controlled by the framework itself. There's a question. Is there a service hook method that must be implemented? Yes. So on start command is one example of a hook method that must be implemented if you do a started service, and that's where you receive the intent that's passed via the start service call. We'll look at some examples here later, very shortly. With bound services, there are other hook methods like on bind that get called back, and based on what on bind returns, you typically give back something that's either a messenger or some other kind of a binder object that can be used to send data back and forth between the client and the service. And those, of course, themselves are proxies and servants, or as they call them in Android, stubs that carry out the work, and those use hook methods as well that you have to override to fill in the blanks. Let's see. I talked about system services having special privileges. So you need to take a look at the security model of Android to understand how the privileges work. Those topics will be covered in the next MOOC in the specialization when we start talking about mobile security. So there's a whole security framework with permissions and so on. And I'm not going to go into that right now because it's outside the scope of this discussion. But you can certainly go and look at the videos if you're interested, and you'll learn more about those kinds of things. Good. Here's a great question by a C++ programmer. Good question. So are bound services similar to an object request broker? Yes, absolutely. So you'll be amazed when we get to bound services. That'll probably be towards the end of next week. When we talk about bound services in this class, you'll see that they implement the broker pattern, which is identical as a pattern to the broker you'd expect to see with Corba, Java RMI, DCOM, if anybody remembers DCOM back in the day, and other sort of remote procedure call and remote method invocation broker architectures. And the Android bound services mechanisms are just a wonderful example of the broker pattern applied to inter-process communication within a device. And even, of course, modern forms of web services and JSON use brokers as well. So things like retrofit uses the broker pattern. Any kind of RPC mechanism that's used with SOAP or JSON in the web today, that also uses the broker pattern and so on. So yes, that's a good observation. We'll talk a lot about that. It's kind of fun to see these patterns that were applied so widely back in the 90s for distributed object computing reappear in the teens for use in mobile device programming. Should the callbacks be blocking or non-blocking? Should we implement threads or rules in these callbacks? Well, obviously it all depends. It depends on the context in which the callbacks occur. So this is a topic that you really should go back and watch the discussions in the previous MOOC about for concurrency. And basically, if there's short duration operations like displaying an image or getting text typed in by a user, those can be blocking, but they're not really blocking. They're just making a method call and doing something that takes a short time to run. I think the real question is not blocking or non-blocking. It's really short duration, long duration. So if things are going to take a while to run and they're called in the context of the user interface thread, then of course that's going to be a problem. And you'll see some discussions of that shortly when we talk about services. But across the board, don't be doing long-running operations in the user interface thread. If you're going to have callbacks that take a while to run, then arrange to run them in another thread, either one that you spawn, one that uses the async task framework, one that uses the executor mechanisms, the executor framework that Java provides that you can use with Android, intent service. There's gobs of things, bound services with AIDL. There's all kinds of ways to run things concurrently in Android if it takes a long time to run. Okay, so I think those are the questions for right now. Let me go ahead and continue on. Let's see, let me bring back up my slides. All right, let's go find out where we left off. There we go. Okay. So make that visible. Hold on a second. There we go. The next topic is how we go about integrating a service into an application. And this should be familiar to you by now if you're familiar with how Android works in general. So the Android service framework provides a semi-complete portion of an application. That's what makes it a framework. So you have Android with a bunch of components, and then you have your application components, and you have to integrate them together somehow. And of course, you use a manifest file to do this. You can read here for more introduction to manifest files. I'm assuming people know manifest files by now. In a nutshell, the manifest file tells Android how the activity and the service components will plug in to the overall frameworks. So this is, of course, the activity manager service that handles all this stuff under the hood. What you would do is you would add the service to the manifest file. So here's what you can have in a service. These are the service elements you can have in a service portion of a manifest file. So you can have the service be enabled, true or false. You can have it be exported, which means it's visible to anybody else besides this application. You can define the icon that goes along with it. You can say whether you want the process to be isolated. You can give a label for the thing. You can give a name. You can give permissions, and you can also say whether you want it to be a process to run its own process or not, and if you want it to run a process, what you want the name of that process to be. Some of these things we're not going to talk a lot about. We will come back and talk about process in some detail because that's important. This is a good example of what you might do if you had a manifest file. You could come along and say, I'm going to have something called the download service, and I'm going to not export this thing by default. So I want it to only be visible to this application, but nobody else. Here's the name. Notice that services do not automatically run in their own processes or threads. That was an earlier question somebody asked, and the reason why that is the case is it doesn't need to be the case. There's plenty of situations where you don't need to have a service running in a separate thread or process, and I'll show you an example here in a minute. You could also go ahead and define the service to run in its own process, which again by default will be single-threaded unless you do something to the contrary inside of it. But this is a way to run the process separately. And the reason you would typically do this would be several-fold. One is you might want to make your application more robust. So if the service was to go berserk, it wouldn't hurt the activity process. You might also want to do it if you want to share the service between multiple applications. And there's a couple other reasons as well having to do with garbage collection we'll talk about later. So let's talk about service deployment models. So a started and bound service can run in the same or in different processes as their clients. So here's an example where we might have an application that has an activity and a background service, and we can either have these things located in the same address space. So I guess, let me fix this a second because that's a little confusing, and I don't want to forget. Let's see. Let's go here. So in this case, we would just have the main process, and the things would be running in both of them. And then, there we go. Whoops, sorry about that. So in this approach, we would have the activity and the service in the same process. And in this approach, we would have the download service running in a background process. You can write the code identically, and then you can configure the behavior in a declarative model. And this, of course, is determined by the configuration setting of process in the manifest file. So it's real easy to switch back and forth between these two different models. So here's basically what you do. You go from this approach to that approach. Here are some of the reasons why you would run a service in its own process. And you can read here for more discussion about this. Services that are shared by multiple applications need to run in separate processes. So if you have a service that's going to be shared by multiple elements, then it needs to run in its own process. Otherwise, it can't be shared. There'll be a copy for each application it runs in. And here's an example. This is from Android. The Android Bluetooth service is an example of a shared service. So it's shared by multiple activities that run in different processes. Giving a service its own address space, which is what you get when you run it in a process, can make the application more robust if the service goes berserk. So if the service goes berserk or hangs or fails, that won't necessarily affect the activity if you program it properly to be defensive and robust. And then also there's this issue of garbage collection. So if you're running things in separate virtual machines in separate service processes, then that garbage collection won't affect the application process. The application process could remain more responsive, and if any garbage collection took place, it would take place in the background service, which wouldn't affect the activity in the foreground process. Now, this is all well and good to have all this flexibility, but at some point, we've got to figure out how to communicate between the activities and the services. And that's what a lot of the focus in this course is going to be about. How do you talk back and forth between these different things? Under the hood, there's something called the binder framework, which is a remote procedure call model. And that's used by a bunch of different inter-process communication mechanisms in Android. You can read more about the binder here. We'll talk a lot more about the binder before we're out. And the binder can be used to support two-way or one-way client-service communication models, and we'll also see that you can use it for synchronous and asynchronous processing. One approach that it supports is basically to use method calls. So you can invoke methods. This is what's typically done with bound services in AIDL. You can also pass messages in one-way messages from an activity to a service or a service to an activity. And basically, you can construct things in all kinds of flexible ways. So it's up to you to decide how it is you want to have these services actually work and communicate with each other. That's up to you to decide how to do. Obviously, if a service runs in its own process, then you have to be more generalizable about how you exchange data. And that's one of the things that the AIDL compiler, the Android Interface Definition Language compiler, does for you under the hood. It manages all the complexity of moving the data back and forth. And we'll show a lot of examples of that shortly. Okay, so at this point, let's see, we don't have any questions, so I'm going to keep going. If there's any questions, please feel free to jump in. What I'd like to do here is show you an example application that uses services. So this example is going to be able to play music via a started service. And here's kind of what it looks like. You have a way to type in a URL, and then you hit play, and it starts to play. And when you hit stop, it stops playing. So you start to play, and the music service will continue to play music even when the music activity leaves the foreground. So if you go ahead and bring along a different application, like you bring up the download application, the music activity will still continue to play in the background. So just to make that humorously clear, let me go ahead and fix a couple things. I just realized I have to fix this too. So even after we go ahead and start a new activity running, our music player will still continue to play music in the background. And that's because we're using a service to do this as opposed to an activity. To stop the service, you just press the stop button, and that causes the music to stop playing, although the service doesn't go away. And here's how things work under the hood architecturally. So the music activity is going to send an intent to start service, and that intent will contain data that indicates which song to start to play. And when you click this thing, the music service is started on demand, and that's because it's a started service. So it begins when you click the play. That's what's going to start it. And the way this works under the hood, of course, is to use something called the activator pattern. And the activator pattern is a very, very widely used pattern. If you're familiar at all with Unix super servers like inetd, that's the activator pattern. If you're familiar with things like the way that orbs are automatically launched, that's the activator pattern. The way that activities and services are started on demand, that's the activator pattern. And basically that enables efficient and transparent on-demand activation and deactivation of services that are accessed by multiple clients. And we'll talk more about this pattern later, but feel free to take a look now at this link and you can read more about it. It's kind of cool. When the service first starts to run, its onCreateHook method is called. And that will do some initialization that's done the first time the service starts. And then the onStart command is going to be called to play the song that the user actually requested. That'll be called every time somebody called start service. The music service is also stopped on demand via a call to stop service that'll shut things down. And that will cause the onDestroyHook method to stop playing the music. And now let's go ahead and take a look at the code. So here's basically what the overall design looks like. We have a music activity and a music service and a bunch of methods. And this is where the code actually resides. So let me now go ahead and go share my editor instead. Let's see, stop sharing the slides, bring up my editor, my trusty Emacs editor. There we go. Okay, so this is the music playing service. So if you go and you download the code from GitHub at that link, you'll find this. As you can see, it's got the music activity, and the music service. And this particular service is actually started on demand. Now, it turns out that's actually probably not the very best idea. I'm doing this just to show that you can start services via implicit intents, but it turns out not to be a very good idea to start a service via an implicit intent. And the reason for this, of course, is that unlike activities, which will prompt you and give you a chance to deconflict if you choose, if you have an intent that identifies multiple services, you don't typically want to do that with you can do that with an activity, but you can't do that with a service, or you shouldn't do that with a service. So this is just showing you how to do it. It's obviously easy to change this to be an explicit intent. Here's the music activity itself. It extends activity. We have our logging tag. We have a default song that just plays some mindless techno rave music. Here's the link that the user edits or enters for the URL of the song to download. Here's the intent that's used to start and stop the music service. Here's the onCreate command on the activity. It does the normal things. It sets the default layout and caches the edit text resource, or stores. Let me change that to store the edit text resource. Here is play song. Play song, of course, is connected to a button via the layout resources file. And what this does when you call it, it makes an intent that will be connected to this URL that the user provided, and we'll look at that in a second. And then we go ahead and start the music service via the intent. So the service gets started here. When someone wants to stop playing a song, we go ahead and call stop service, and that will turn around and tell the service to stop itself, which will, of course, will stop playing the song. And if there's no song that's currently playing, we'll show a toast that explains that that's the case to the user. And then here's the get URL string. Get URL string just takes the user input. If it's a null, it uses the default song and returns that. And show toast is just a toast that's displayed to the user. So you can see, pretty straightforward, pretty simple. Note this particular implementation stops the service when stop song is clicked. That's probably overkill to bring the whole service down. Maybe, maybe not. Depends on what you're doing. We'll see later how you could use messages to do the same thing without stopping the service. You could just stop playing the song, which might be a better way to do it. Okay, here's the music service. Music service extends service. And that's, of course, so it can go ahead and run in the background. This particular implementation, interestingly enough, runs in the UI thread. So this is an example of a service that does not explicitly spawn a thread. Now you'll see it does some magic stuff later to do some things that run in the background, but this service runs in the UI thread, just demonstrating that it's perfectly plausible to do that. However, it implements the media player on prepared listener interface, and it does this to avoid blocking the UI thread while a song is initially streamed. So streaming a song might require downloading some data, some play into a playout buffer, so that you get a good, continuous, smooth listening experience. And that, of course, could block. And so we don't want to actually block the UI thread while this is taking place. So we use the media player on prepared listener to do this. Here's the intent. So we have an intent here that's basically intent used to start the service. Now, I said before, if we do an explicit intent, we don't need to give it an action like this. We'll take a look at that also. You can keep track of whether a song is currently playing or not by having a Boolean. We have a media player, which is an Android object that is used to play songs. Media player is very powerful, basically uses the state pattern to do its work. Here's the make intent method. This particular implementation uses an implicit intent. Like I said, you rarely use implicit intents for services. You're better off using explicit intents. This is just illustrating you can do that, but I probably wouldn't do that in production implementation. Here's the onCreate method. onCreate calls up to the superclass. and it creates a media player that'll be used to play the requested song. And it says, I want to stream the audio that I'll be giving later once the user actually gives me the URL to download. Here is the onStart command. This gets called back every time start service is called. onCreate only gets called the first time a service is called. onStart command gets called every time the service is started and the intent is passed. What this does is it goes ahead and it extracts out the URL as a string from the intent. And then if the music player is currently playing a song, it'll stop playing the current song because we're going to switch over to another song. We then go ahead and tell the media player, this is the URL to the song that I want you to play, please. We then tell the media player, please call me back, me being music service object, please call me back when preparation is finished, when you're done streaming enough of the data into the playout buffer that you're willing to start playing the song. And then we call a method called prepare async. Prepare async, unlike prepare, doesn't block the caller. It just goes ahead and probably in the background uses the Hammer framework or some other means. We don't know unless we looked at the implementation. I think it might use actually a C or C++ level threading and queuing mechanism that it is not unlike the Hammer framework with respect to the command processor pattern or something to do its thing. We'd have to look at the code to know for sure. But that basically goes ahead and says, start streaming the data for this link, but don't block the calling thread. So at this point, we're going to return a flag that says start not sticky. That says don't restart this service if the service has to be shut down for some reason, like we ran out of resources in the computer. And then onStart command is done. So whenever media player is comfortable that we've streamed enough of the data, then it automatically calls back the framework. The Android media player framework will end up calling back the onPrepared method, passing in the media player that the prepare async call was made on. And that then goes ahead and plays the song one time, and we note that the song is playing, so that if we're told to start playing another song, we can stop this song before we start playing the other one. So that whole thing takes place asynchronously. Here's the onDestroy method. This gets called back when the music service is stopped, and as you can see, it just calls the stop song method, and stop song stops playing the song, resets the state machine of the media player back to the beginning, and then notes that there's no song that's playing at all. So those are the main steps in this particular implementation. Here's the onBind method. This is another method that always has to be implemented by a service. If it's a started service, it returns null. If it's a bound service, it returns a binder or an iBinder, a reference to an iBinder. And that's how Android differentiates between started and bound services. What does onBind do? Okay, so that is basically the implementation. I'm going to go back quickly and wrap up some discussion about this stuff, and then I will go ahead and take questions about this. It's a short example, but it's a fun example because it illustrates a whole bunch of things about services without having you need to know a lot of complicated stuff about concurrency. All right, so let's go over here. And we will, here we go. This is where we're going to pick up. So, whoops, wrong one. Okay, so now that we've covered the code, let's just kind of wrap up the discussion of this example. This is a very simple example of a started service. That was done intentionally, of course, because I wanted to do something that wouldn't require understanding all the communication mechanisms that we have to learn about to use services. What makes it simple? It doesn't spawn any internal threads explicitly. That's all handled by the media player framework. And it uses the asynchronous features of the media player. You can take a look here to learn more about how that works under the hood, or read the source code, which is kind of cool. Moreover, services with long-running operations may need to run in separate threads explicitly, and we'll see some examples later. You'll get a chance to write some examples later that do that using the intent service or other mechanisms. And there's also no communication from the service back to the activity that invoked it, which works for something like a music player, which just uses an output device, which is the speaker on the phone or the headphones to display the results or to output the results. But of course, in real life, you often need to get something back. And so we'll talk about inter-process communication mechanisms later. Okay, so that was the example. Let me now go ahead and take some questions. What mechanisms are used to protect resources used among many clients? So I'm not entirely sure what you mean by protect resources. We'd have to dig a little deeper into what we're talking about here, but I'll take a guess, and you can jump in if I go the wrong direction. So let's say the resources would be things like, I don't know, files, or well, files, videos, movies, audio, other kinds of information in fields in a database or whatever, right? So if you're going to have many clients access that information, you typically do one of several things. You either use a service and then mediate access to that content via the service, and you could have a service run its own process, and then you could use either the intent service, which is kind of a single-threaded concurrent model internally to the service, or you could use a pool of threads. We'll talk about that, or you could use the AIDL mechanisms. There's lots of ways to be able to grant concurrent access to resources using services, and that's not uncommon. And of course, if you have multiple threads running around inside a service, then you may need to use things like Java synchronizers to coordinate access to them. So either monitor locks, or you could use reentrant locks or semaphores or whatever, right? There's a lot of things you could use to make all that stuff work. So that's how you, one definition of protecting access. You might also be storing things persistently using a content provider and some kind of backing store, like a SQLite database. If that's what you're doing, then SQLite has mechanisms that are built in to do concurrent access. And it's not very well documented, and we'll talk about that when we get to the content provider material in the next MOOC. But you could certainly, if you wanted to, use the SQLite DIT mechanisms, which provide implicit serialization within a process. So that's another way you could do it. So again, if that wasn't what you were asking, please ask it again, and I'll come back to it. Let's see, Corey liked the music player example. Yes, I like the music player example a lot too. If you download the code, you'll see how it works. It's pretty cool and easy to understand. But keep in mind, it's a very simple example of a service. And it's also cool because it shows how you don't have to have a service run in a background thread or process to be useful. And that answers one of the earlier questions about why did they choose to have services that would run in the UI thread by default, because you can always change your mind if you want to. If they didn't do that, if you always had a service run in a process or run in a separate thread, then you would add extra overhead for situations like the music player example that didn't need to run in a separate thread or process. Let's see, there are many advantages of using a separate process for the service. Why would you use a single process service? Are there any advantages to run a service in the same process as an activity? Yes, it's a lot less overhead to communicate between things in the same address space than if they are in different address spaces. So communication costs go way up when you're talking between processes versus talking in the same process. By the way, the vast majority of services in Android run in the same process as the activity that starts them. So I'd say 99.9% of those in Android. Now, of course, there's also system services which don't run in the same address space. And I'm not counting those. I'm counting the application-oriented services. But you could also have your own services that ran in background processes. And it's important to be able to know when to do both. Let's see. There's an observation that only real nerds use Emacs. That is absolutely true. I've been using Emacs since 1985, and it's at this point, I don't think I could use another editor and be as productive as I can with Emacs. But having said that, I also use other stuff, including touch screen devices, which are not Emacs, regrettably. Is there some sort of timeout before a bound service is destroyed after all clients unbind? No, there's no timeout. It's simply the last client that unbinds triggers a callback into the service implementation that causes it to shut itself down. So there's no need for a timeout. Have a service wait for a while just in case clients bind. Yeah, that's not the way things work in Android, by the way. In Android, you're really not supposed to keep things running for any length of time if they're not being used. And so the whole notion of running a service, a long-running service, is something you do very, very sparingly in Android. Not to say that you don't do it, and not to say Android doesn't do it. Android has a bunch of services that run all the time, like the Activity Manager service. It's just not something that people typically recommend. If there's good reasons to do it, by all means, go for it. But they don't optimize for the case of keeping things running. Now, having said that, it's also possible to have hybrid started and bound services where you won't actually have the service go away when the last client unbinds. And I'll talk about that later when we get to other parts of the course. When you call the player stop, should you check whether it was started? I think that I don't think if it hasn't been started, then it doesn't do anything, and that's checked for in the activity. If you take a look at the music activity.java file, you'll see that it keeps track of whether or not the intent is null, and if the intent is null, that means it hasn't been started, and so it won't do anything in that case. So yes, that is actually checked by the client. Corey asks, are there any advantages to running a service in the UI thread? Sure. If you don't need to have additional threads, not creating additional threads is a win. And the music player example we just looked at is a great example of something that didn't need to have an explicit thread. So having it run in the UI thread was perfectly fine because we used other mechanisms in order to be able to get the concurrency we needed out of the implementation by using the music player's prepare async method to do the work. With regard to live lectures, are they all planned for a similar time of day? Well, as you might expect, Sherman, there's no good time that's convenient for everybody. So what we've been doing in the other courses is typically having them at 10 o'clock in the morning Central Time. I'd be happy, now that school's out, I'd be happy to move some of them back a little bit, but I'm not sure it's going to help a whole lot. The good news is, of course, that all these video lectures are turned into videos. I post-produce them and then I upload them so you can watch them at your convenience if you can't make them here live. And so that's one thing that makes it doable if you aren't willing to get up at crazy hours of the day and night. Okay, I think that was all the questions for now. Let's continue on. What we're going to do now, since of course one of the big themes in this course is concurrent programming, we're going to talk about concurrent programming with Android services. So started and bound services can run in the same thread and process as the client, or they can also run in different threads and processes. You can either do this based on programmer logic, in other words, you can write the code that imperatively decides where things run. And you can do that by extending intent service, starting a Java thread, using the executor service thread pool, et cetera, et cetera, et cetera. Or you can configure your choice of running something as a process in the Android manifest file. So there are two different ways to do it, imperative and declarative. By declaring something to have the process field. And you can read more about that here. Services that are shared by applications must run in separate processes. We talked about that before. And that allows things to be more robust. under various circumstances, as we mentioned before. If you do this, of course, you have to communicate via IPC mechanisms, and the typical mechanisms are intents, messages, handlers, and AIDL. We'll talk a lot about those. And of course, surprise, surprise, there's lots and lots of patterns, both gang of four patterns and especially POSA patterns, that are used to guide the way in which these inter-process communication mechanisms take place between the activities and the services. And we'll talk a lot more about that as the time comes along. Ones we'll talk about: activator, command processor, proxy, broker, and so on. Other ones that are there: template method, command, active object, publisher, subscriber, and so on and so forth. All right, someone had asked this question before, and it was a good question. Where are services applied? So here's a little summary of some of them. There are more, of course, but these are some ones that are good to start with. So here are some examples of services in Android that are both started or bound, and in some cases they're both. The SMS MMS facility in Android, the SMS and MMS application in Android uses a started service to do things like send and receive the data. And it uses a service that runs in the background, of course, to receive the data that comes in and to notify the client. That one has to be running when messages come in for the calls to take place to the user to alert them. And that can also be used to buffer stuff up on the way out too, if you chose to do that. And then it's also used for handling calendar event reminders. So they have an alert service that's used. These are both examples of started services. There's also a bunch of bound services. The Bluetooth headset, which gives you headset and hands-free operation for the phone application, that uses a bound service. Very interesting service is the media playback service. This is the thing that under the hood implements the media player object that we saw in the music application example. And this is an interesting service because this is both a bound service and a started service. And the reason for this is that they want the service to continue to be able to run even when all the clients go away. But they also want to be able to send commands via AIDL method calls. And so it's a very, very interesting service. I highly recommend you take a look at it. I might walk through some of it later just because it's fun to look at. And then there's also the exchange service that's used to send and receive email messages, which have to run in the background, of course, and also to receive messages in the background. So those are some of the many examples of services that you'll find in Android. And again, the best way to learn about this stuff is just to do download the source code and then grep for extends service or extends intent service, and you'll find all those examples and many, many others that I didn't summarize here. Okay, well, that is actually the end of the slides that we're going to cover today. Naturally, I'll be happy to take some questions, but before we depart, I want to go ahead and show you a couple things that might be worth looking at. Let me go ahead and bring up my browser here. Okay, so this is the page for the course itself. This is the communication MOOC, as you can see. And if you go here, you'll see that I've uploaded some of the supplemental lectures for the first 2 weeks. And as you can see here, we've kind of gone through the overview of Android services. And the next thing we're going to do is go into a lot more detail about programming started services. And we'll cover that on probably Wednesday this week. And then we're going to go through the Android intent service. And that will cover sort of all the started services stuff. Then next week, we're going to start talking about communication between these things. And we'll talk about activity and service communication, and then we'll talk about doing this with Android messengers. We'll talk about bound services with messengers, and then we'll talk about using the Android interface definition language in the binder framework. And that's all stuff we'll cover. These are really, really interesting things that you might want to take a look at to learn more about what's coming. But if you don't want to, just wait and we'll cover them in the class. By Wednesday, I will put up the first programming assignment and the first quiz. And of course, the programming assignment will deal with things related to the topics we cover this week. And just like we did for the last course, it'll stretch for 2 weeks. So some of the stuff that we'll cover that you'll be part of the first assignment might be in week number 2 of the course, but that's okay because you can either watch the videos or you can always just wait and start on that part after we cover the material. But in either case, you'll have access to what you need. And we have discussion forums. Those are all split up. For those of you who took the class last time, you should be very familiar with this. We've already got some people who've begun introducing themselves, which is great. The syllabus is up here. You can see all the topics we're going to cover. And probably starting in week 3, we'll start the Android IPC stuff. That's going to be done a little bit differently than these lectures. So these lectures, as you can see, are largely live with some supplemental material. The IPC, the remote IPC mechanisms, the ones talking about HTTP programming and retrofit and so on, those will be done by Professor White. And he has a very fascinating style of doing his lectures where he uses a light board. So they will not be live, but they're almost as good as being live just because of the way that they look. And so he basically writes on the light board as he's talking. And people tend to really love the way that he does his lecture style. So that's pretty cool. Okay, so let's see if there's any more questions. When can we expect the grades for the previous course? So I've actually gone ahead and we've computed everything at this point, and I'm just waiting for the right person from the group here at Vanderbilt who controls the release of the grades to push the button. And those things should be done very shortly, in a couple of days at the most. I mean, there's no reason they shouldn't be done today, but I don't have control over who pushes that button and when they push the button. So I suspect it'll be pretty soon. Next question, our office hours, Wednesday or Thursday? We're going to do it Wednesday this week. Usually we do them on Wednesday until we start to do my solutions to the assignments, and then we do them on Thursday. And the reason for that is that way people can turn in their solutions on Wednesday when they're due, and then on Thursday I can go over my solution to the assignments. And so it'll basically be more or less the same as last time. I'll go ahead and schedule that and send it out here shortly so you've got it on your calendar. Okay, any other questions people have? Let's see. All right then, so what I will do is I will go ahead as always and will download and do some light post-processing of all the videos that we made today, split them up into smaller parts and upload them to Coursera. And the whole process will start with subtitling and recoding so they're downloadable in MP4 format from the web. And as you know, if you took the course last time, that process takes a couple of days, which is why we started a day or two early, just so we would get things up and running. But I thank you all very much for attending, and I look forward to talking to you again soon.